Today we'll see remaining part in digital communications. Okay. So in the digital communications, we have seen what are the important topics for or what are the syllabus for GATE examination is pulse digital only. Okay, not pulse analog. So in the pulse digital, we have seen pulse code modulation, and that is the main one thing. We have seen about those things. What is the pulse code modulation? How that regenerative circuit is regenerative or repeater circuit is useful to increase the signal strength while transferring in between the transmitter and receiver. That is in the channel. Some noise is added means how it will be. And now that how electrically signals are representing using different methods like return to zero method, return to zero signaling, non-return to NRZ, non-return to zero signaling, binary signaling, all differential encoding, all we have seen about, and the encoding type also we have seen. Now today we'll see is a matched filter. Okay, so during this transmission, what is this matched filter? And we'll see about that signal to quantization noise ratio, and how the probability of error is we are going to get. All these things we will see today. Probability of error and different probability of errors for ASK, PSK and FSK, and we'll see what is information theory and what is different types of coding techniques we are using to transmit that information, and what are the information techniques and channel capacity, how is this channel capacity, what are the codes we are using there, and we'll see all these topics in today's lecture. So the first one is matched filter. This is a very, very important topic for GATE examination. Okay, see, I'll tell some topic, this matched filter I will tell first, explain how we need to get derive. We are going to derive the matched filter. Then we'll see some problems, some previous problems about this matched filter receiver. Matched filter receiver. Okay. So here, this matched filter receiver, how we are going to derive this? How it is going to perform? Okay. Plus signal S of t, noise N of t, signal S of t, noise N of t, then filter H of t. This is H of t. So next you are getting this. After this filter, one switch will be there, and this is the one. Next, this we are going to give a threshold comparator. So other input is VTH, and this is the output. Okay. So here what is going to happen? This is the signal S of t and noise N of t. So S of t you will get it here and N of t you will get it here. So this filter transfer function H of t, then you will get a transfer function H of f. This is time domain and this is frequency domain. This is S naught of t, N naught of t. That means signal output. This is the final output. This we are going to compare and then we are giving. So signal and noise component both we are getting. Okay, this signal to noise ratio, this is TBT, TB bit rate. Okay, how this switch is going to vary with how much bit duration, what is the sampling time of that one. Okay, so based on that you will get this signal to noise ratio maximum, S by N, signal to noise ratio. This is only based on this signal to noise ratio we can compare and we can get the output. So here output what you will get it, this is TB, this is TB, TB greater than VTH, then it gives as output 1. TB less than VTH, you will get output 0. This is the output. Okay. So this is a just comparator, two signals it will compare. If this TB, this we are calling as a TB, if this TB is greater than this one, then you will get output 1. If this TB is less than threshold voltage, then you will get output 0. Okay. So if signal to noise ratio greater than 1, okay, signal to noise ratio. So if this is greater than 1 means signal power is more, noise power is less. So the signal to noise ratio S by N greater than 1 means, so noise, then error is very low. We can say then error is very low. You can say like this, error is very low. So how to derive this signal to noise ratio? So derivation is not an important in this case, but I am just deriving how we will get. This might be useful in some interviews, only, mainly whatever it may be, like PSU interviews or GATE examination. After getting a rank, you have to apply for IITs and IISc. So they will call for again one more exam, some IITs, and both exam and interview in some IITs only. Okay, IITs. So S naught of T is equal to, that is the filter output, S naught of T is equal to S of T and H of T. Okay, so S of T convolution with H of T. Okay, this is in time domain. So if you take S naught of F, so this convolution in time domain becomes multiplication in frequency domain. S of F into H of F. So both will become capital letters. Okay. So now this is in frequency domain. So you know, from time domain to frequency domain, time domain convolution will becomes multiplication in frequency domain. So now S naught of T, S naught of